Great. Well, welcome everyone to our event. This is part one of an event on remote sensing and smart tech for marine litter. We're really delighted to be with you under the UN Ocean Decade Laboratory satellite activity. My name is Janet Salem. I'm with the UN Economic and Social Commission for Asia and Pacific, that's UN ESCAP, and I'm the project manager for a project called Closing the Loop, which aims to use smart tech to monitor plastic pollution in cities in Southeast Asia. So this is a topic very close to my heart. I came into it quite fresh about 1.5 years ago, and I've had a very steep learning curve thanks to some of the experts you'll be hearing from today. So I will just share my screen and introduce the session. Okay, great. So you see the session, this is session one of our event. There are actually 3 different parts to it. The first one will focus on the end users and the economic and societal stakeholders. So these basically who really can benefit from remote sensing and smart tech for marine litter, and what should we be doing with that information once we have it. But there are 2 more sessions after this, which will focus on those technologies that enable us to monitor the plastic pollution. Now, there are several organizers that have come together for this work, including the United Nations ESCAP, but also members of the International Ocean Color Coordinating Group, the Institut de Sciences del Mar, Algae, the University of Oldenburg, Plymouth Marine Lab, Inestech, the University of the Aegean, and Air Centre. Air Centre's done a phenomenal job putting this together. So a few rules. The event will be recorded and is also now live in the YouTube channel provided. Participants will have their mic and camera off at all time, although we would love to see you. Wish this could be an in-person event so we could interact with you, but it'll be off. But you can report your questions to the speakers and provide your comments on the Padlet at the link below. I'm gonna have to ask one of the organizers to pop this in the chat, since I'm in now full screen, so I won't be able to do it right now, but as soon as I'm off full screen, I'll put it in there. We have 6 speakers, some extraordinary gender balance, I must say, compared to some of the other events on this topic that I've been to. So apart from myself, I'm very, very honored to be sharing the session with Sabine Strnad from the Alliance to End Plastic Waste. Then also Amandine Declerck from Suez, France, Vitor Verdelho from the European Algae Biomass Association, Manuel Cruz from the Port Authority Aveiro and Figueira da Foz, and Mariana Lara from AQUA-LIT in Hungary. So I'm going to just give a quick intro into the policy perspective, which is where I'm working within the UN. There are a lot of international, national, and now city level policy frameworks trying to address this plastic pollution problem and preventing the buildup of marine debris. Starting at the very global level, we have the Sustainable Development Goals, goal number 14, which is on life below water. And under that, there is a specific target, 14.1, the very first target there, which is that by 2025, we want to prevent and significantly reduce marine pollution of all kinds, particularly from land-based activities, including marine debris and nutrient pollutions. So 2025, it's only a few years from now, and this is a goal that is common to all member states, but particularly those with coastlines. Then zooming down at the sub-regional level where I'm working in, here's another example. This time it's the ASEAN Regional Action Plan for combating marine debris. So again, a multilateral space where they've come together and agreed that they need to cooperate and build robust national actions to address marine debris in the ASEAN region. It is a hotspot for marine debris. So this roadmap was actually just launched a few months ago. So it would be great to see how we can support the policymakers in this action plan regionally, but also in the national level, and I think city level would also be very, very helpful, so that they can keep an eye on the goals under this action plan. Another example is the G20 Osaka Blue Ocean Vision. So here we have the G20 countries of the world who've come together to agree to reduce additional marine plastic litter to zero by 2050 through a comprehensive life cycle approach. Now, I won't be able to go through all of them, but these there are also other regional strategies that can benefit from monitoring, and then other enabling strategies like the UN data strategy or roadmaps for digital cooperation, which can support smart tech and for the smart tech that underpins remote sensing for marine debris. So even if they're not plastic oriented strategies, we can also look at support from there. And then national level. So across the Asia Pacific region, but also globally, we've seen a lot of national plans and national goals to manage and prevent marine litter. I won't go through all of them, but I do want to give one example of what does it look like when the multilateral system attempts to use smart tech to measure, monitor, and prevent marine debris. This is my project, the Closing the Loop project. So our goal is to help the cities because they're at that last mile before the ocean. So we want to help them to prevent marine pollution. But in order to do that, they need two things. They need an evidence base and they need a monitoring system. So in order to do that, we want cities to use innovation and smart tech to support their monitoring and their measurement. We have 4 cities across Southeast Asia, one in Thailand, Malaysia, Vietnam, and Indonesia. So we see this as a 3-step approach to preventing marine pollution from cities. The first one is that you need to measure. That's the baseline assessment that is quite a data intensive effort of primary data collection that attempts to answer questions like what's the source of the plastic pollution, which products is it, and where are those leakage points. Then we have developed a digital mapping tool, which I'll go into in more detail later. And then those 2 instruments can then enable the city action plan. So let me just go first into the measurement. So what is quite complementary to the plastic pollution monitoring using remote sensing is to do the on-the-ground plastic baseline measurement first. So we use the plastic pollution calculator in cooperation with the University of Leeds. It's a material flow based methodology where we collect data. Each of these squares is a data set that we collect to determine how much waste is generated. Of that, how much is properly managed, how much is dumped, and of those 2 streams, how much enters the environment, and of that, how much actually enters the waterway. So we can get pretty accurate pictures of this, and we end up with things like this, these Sankey diagrams that show us of all the plastic waste generated, how much becomes marine litter. So in Surabaya, it's about 2% of all plastic waste. Kuala Lumpur, it's 0.4%, Da Nang is 1.3%, and Nakhon Si Thammarat is about 1%. Now, all that sounds very small, 1%, 0.5%, 2%, but behind that is many millions of plastic items every year from these individual cities. And if you add up all the cities around the region and around the world, it all adds up. Okay, seeing some good chats already coming through, so please keep them coming. Now, I'll just also point out that the plastic pollution calculator also calculates how much of that plastic is retained on land, not in a landfill, but as litter, mismanaged. So that is also that also has potential over the long term to leak into the waterways. Oh, there we go. We also learn what the products are. So this is really useful to know when it comes to that action plan, which products do we need to address? And overwhelmingly of all the plastic waste that actually enters the water, the majority is often the plastic bags. So no wonder we see bans on plastic bags coming. Depending on the city, there can be very different pathways. So for instance, in Kuala Lumpur, it's not a coastal city. So the pathway of pollution is from the drains. Whereas in Da Nang, beautiful coastal city in Vietnam, half of it is the plastic pollution is dumped directly into the water. The calculator also tells us what time of year the pollution is more likely to enter the water. And many other things, but I'll move on. So once we have that measurement, that's already enough to inform the action plan at the end. But before we start that action plan, we want to put in place a monitoring system. And this is where the use of remote sensing and smart tech comes in. So we've developed a digital mapping tool, which takes data in through satellites and sensors. It processes it and it puts out some data. So in our case, the types of remote sensing we've gone for in the cities is satellites using Worldview 3 data, citizen science through mobile apps, and GoPros on vehicles. So those are our sort of eyes on the ground. Then there are two types of algorithms that detect plastic in those images. One set of algorithms can look at the satellite images, because that contains a lot of information that's not visible to the eye or to the computer, but it is visible in the data behind the satellite images due to the way that the plastic absorbs light. Has its own spectral signature that apparently is visible if you use the right algorithms. Whereas the cameras, the GoPro and the citizen science methods, that's a different set of algorithms that just detect the shape of plastic in the pictures. But we need to then process that all together so that the people managing those action plans can see something like a hotspot map. And then over time series data is very useful if possible. We can see if that plastic pollution is increasing, hopefully decreasing, or is it moving around due to some change in that plastic waste value chain. Now it takes a bit of work. We need to determine, this is Da Nang, in each case, what the areas of interest are for the different types of remote sensing. The blue is the citizen science and the GoPros, whereas this purple is satellite data, and the stars are some visual counting sites to ground truth those remote sensors. And in each case, we need to develop a data workflow to figure out which technologies are going to be used in which way to answer which question. I won't go into many details, but it's not super easy. But all of that is worth it, because then we get to the city action plans where we can identify those policy intervention priorities. So we know it's the bags, it's the littering, it's a certain district, it's a leakage from a certain part in the waste value chain. It's through the drains, or it's direct into water. So we know then we can target those hotspots. And then based on the qualitative information, which I forgot to mention before, we can then develop local action plans that are suitable and relevant to the local stakeholders and the capacities that are available in the city. We also have an e-learning course. I'll pop that link in the chat if you want to learn more, including there's a special module on remote sensing. So I will end my share here. And just say, if you have any questions for me in particular, please feel free to pop them in the chat or in the Padlet. So the Padlet link has been shared in the chat, and we'll keep an eye on it over time. All right. So that was a little quick intro into how we're approaching it, but it's not so easy, I must say. This technology still has a long way to go. So we need more cooperation so that there can be sharing of those best available technologies. In our case, we need more help to detect the plastic in the images that we're getting. And we're also hoping that the cost of some of that satellite image data will come down over time. That would also be extremely helpful so that we can collect more regular satellite data, because we've noticed that the cities are asking for real-time data from the remote sensing. But this is actually a little bit difficult because there is a little bit of logistics involved in data collection and processing and uploading of data. But we need to start somewhere and then work together to fine tune and make these systems even better. So that's it from me on my presentation. So what I'd like to do now is invite my wonderful colleague Sabine from the Alliance to End Plastic Waste to share that private sector point of view. What is the Alliance doing with that support of their private sector membership, and how are they bringing data together, and what format of data would be useful from the remote sensing community to support their activities. So Sabine, would you like to start with a quick introduction of yourself, and then we will move to your presentation?
Thank you, Janet. Thank you for the warm welcome. Hello, everyone. I'm very happy to be with you. My name is Sabine Strnad. I'm a senior advisor to the Alliance to End Plastic Waste. This is a CEO-led organization. There are about more than 60 companies which are working together to address the plastic waste problem. And one of the gaps identified is the data gap. And one of the first projects which had been introduced and started with was to identify an open source platform and to develop and work on an open source platform to bring all the plastic waste and municipal waste data together to close the knowledge gap and to identify a way how we can bridge this data gap and what we can do in that respect. We are right now in the beta version. This project is now running about a year. We have a strong collaboration with IBM in that respect. And there is a focus on several data domains. So we work on geography, not only on country data, but as well as lower administration levels. As Janet earlier mentioned, cities are very much interested to see how the situation is in their specific area. We do have the waste management data, and here the municipal solid waste and the plastic waste. We have focused in the first range mainly on that boundary because of the data availability. It's still very difficult, but the aim is then to broaden up to the total solid waste and include also the long duration plastic. But in the first iteration, we are working with the municipal solid waste and the related plastic waste in generation and collection. It's also including policies and regulations here, namely the single-use plastic and EPR, and the mismanaged and the plastic leakage. In order to derive with the mismanaged and plastic leakage, the methodology applied is the UN hotspot methodology, and the way how it is defined, with the caveat that in the UN hotspot methodology, it includes microplastic, textiles, dust from tires, and in the application for prison, taking the boundaries into account, we are looking exclusively on the municipal solid waste and the related plastic waste. The baselines are included in terms of the plastic consumption, and as we have heard in the earlier presentation, it is not it's very much important not only to look into total plastic, but what plastic, which polymer, which application, in order to identify what are the drivers. To help and bring an additional picture to the whole waste data. The waste infrastructure is also covered in PRISM, including informal facilities as open dumps, but as well buyback centers, so they are recorded and publicly available. We have plastic banks and collectors included, and as it is available, the capacity details from the respective companies and the polymers they are dealing with. So the sorting plants, what are they dealing with, the recycling facilities, which polymers are included. And then as well the projects, various projects in place of the members, but as well outside of the membership. The data is available in terms of heat maps and information boxes, which leads to trend lines when there is a longer time of running. And we have as well a data warehouse where all the data is stored with the methodology behind and as well the nature of data. So are we talking about model data or factual data? That's extremely important because we have seen, we have right now more than 800 sources processed in order to get the data into the system. And there are monitored data from governance, municipalities, feasibility studies, but as well a lot of model data available. And when you bring this together in one bookshelf, in one of the data warehouses, and then you put the filter on it, that you have a standardization, that you have using the same definition, there are a lot of learnings out of it. And we saw that as we have got a lot of numbers, but not all the data goes together, and it requires a big amount of work, that there will be more harmonization and standardization on terms and definitions, as well as methodologies, in order to have the data reporting and the interpretation of the data getting into in some more meaningful and comparable manner. Now, we have started then, not very early, but already in summer, regarding how can we use additional information, like information from the satellites, information from citizen science, information from sorting lines from the in details, in order to help with the data we have. We are right now working on implementing the governance and to implement as well, to validate the whole data set what we have, and to bring up a data quality grid in alignment with key stakeholders, that we are assessing the information in the right way. And what we have identified as use cases is that we see in two areas where we could make a big impact. On the one hand, in the area of data validation, and here in the area of quantities and identification of polymer and application, for example, in sorting lines, but as well in litter compositions, and hotspot identification. But the other aspect where we thought it will be very important is in the modeling and in the regression model, to identify the specific archetypes for areas, for cities, for regions where we haven't got any data, where we would like to use with archetype and then a regression model to come up with some first indication how the situation in terms of plastic waste, plastic composition and plastic leakage look like, in order to bring up the right interventions and the first steps in order to improve. We have looked into this, and we with the team several times. The data we have in PRISM is all over historical data. Yeah, so the youngest or the freshest data we have is at least 1.5 years old. That comes because a lot of the data also from governance is not published earlier. We do have predictions in PRISM, forecasting from models and from the implemented and developed regression model, which then goes in the future, which is from today, 5 years, 10 years, 20 years, depending on the model which is in the system. And we thought that, especially when it comes to the historical data, we are not looking for the actual satellite information, but with historical satellite information, we would be already able to substantiate certain data sets we have and to fine-tune assumptions in the regression model. If we would have weather data about cloud and rain, we could help with the flow rates. Yeah, so we could as well here improve the regression model and have additional features and additional information in order to make it more relevant. And in the area of governance, as I said, it's the data validation and the standardization, but as well with this remote data, we would be able to bring back some feedbacks about the data quality we have with real examples. So if you allow at the end some conclusions, as I said, within the working team, we have looked into this, and it would be an interesting aspect. And we are really convinced that this would bring some additional information for the potential user and bring also additional insights. What we would need in order to go into the test case is availability of this data sets. Yeah, if it's satellite information or GoPro camera data or whatever it is, or science data from the citizen science. With this, we could then go in a very concrete test case. We will definitely need even more collaboration and more resources. Yeah, not only financial, but as well human, as Janet said. This is extremely early in stage, so a lot of activity is required. And all in all, it would bring a substantial enhancement to the data modeling and closing the current knowledge gaps. And we do believe that there will be also an improving in the data quality. Thank you. Back to you, Janet.
There we go. Here we are, I'm back. So I was just answering some questions and answers in the chat. It's been really good to see them. So please do keep them coming. And then also on the Padlet, we've got a few. Oh, we haven't had as many questions and answers there. So I might put this in the chat again. So we're looking for sort of questions from the participants here. We see we've got 154 participants at the moment. So we'd like to know, are you, if you are a policymaker or an environmental modelling agency, what kind of applications do you have in mind for exploiting remote sensing data on marine litter? And where would you like to cooperate? So please also let us know about any cooperation interests that you have on the Padlet. If you are a private company or NGO, we'd like to know what kind of applications you might have in mind for remote sensing of marine litter and where you want to operate. Is it the ocean? Is it coastal areas? Or maybe you'd like to work in cities. That would be a great help to me with my programs or other. Or if you want to share some resources, it's also a great platform to do that. So Sabine, not to let you off the hook just yet, maybe you can come back after that presentation. So as I'm sort of working on both ends, I'm both a user of the, I see, I think sorry, if one of my colleagues could share the link to all users. It seems I've just shared it with my own co-panelists. Apologies for that. So Sabine, I would position myself as a user of the remote sensing data, but also a producer of the remote sensing data. And one of the issues that we have is that there's nowhere to put the data once we've got it. But we do know that there's a lot of overlapping programs. So other agencies are working on similar topics, or different stakeholders are interested in this kind of data. And that's why the PRISM program, it's one of those tools out there that is going to help integrate the marine debris data and all of the other data relevant to the origins of marine debris. My question to you is, how do we, how can the producers of us give you data, and how can the users of the data get the data?
Sorry, I was on mute, but now I'm back. Yes, that's an excellent question. We, as I mentioned before, we are still on the beta version. So that means we are at the edge of finishing up and then make it publicly available, which will be somewhere early next year. At that time, we will be not able to host any remote data at the moment, because we are not prepared to handle this. In order to make them store or to give them a place in our data warehouse, we need to understand which type of data do we have. Is it an image? Is it an infrared screen? What is it what we are going to store, and in which application we will then use it further? And if it is in the system and when we are publicly available, then anyone who is registered and has access to PRISM would be then able to pick out the data from the data warehouse. At the moment, it's only the domains what I have mentioned in my presentation. But as I said, this is an aspect which we deem to see that there is a lot of merit in order to enhance the knowledge what we have, and to but we have no storage place, we have no bookshelf created in our data warehouse yet. But we, yeah, I think we need to sit down on the table and come up what would be the priority, which type of remote sensing data to start with, and then go and build the next step.
So you mentioned what type of remote sensing data. I was wondering if you could elaborate more. What should it look like? We've got the experts coming up in the next two sessions that are busy designing these systems. In the UN, we're also trialing and developing these digital tools. What's important for the Alliance to End Plastic Waste? Should it be very regular? Should it be have high coverage? Are the cities important, or the oceans? Or are there different types of remote sensing that are more of more interest?
Depends on the user case. I think we need first to understand with which application we are going to start. When it goes into the area of data validation, for example, in the waste composition, and to understand the composition of the leakage, we would definitely start with a proof of concept, and then it would be a regional area. And again, it would be more historical data, and it would need to meet our data sets that we have in the system. We do have data sets across the globe, across all administration levels, but not unified in 1 year. So we do have for certain countries and cities data around 2018-19, and we have for other areas and other geographic areas data around 2015 and 16, or 2015 to 2019 in a timeline. And in order to have the comparability, then the remote data set needs to fit to the data set in the system. Otherwise, we wouldn't be able to throw out the right conclusions. When it comes to the regression model and the archetype building for leakage per specific archetypes where we haven't got any data yet, in that respect, we would be able to serve with more actual data, so not that many historical data. And again, it would need to fit to specific data sets, what we have already in the system, to have additional features helping to create the pattern and then to define more accurate archetypes. So in that respect, in one sentence, it would be perfect if we have a match between the geography and the years of the data we have in the system already in place and the remote data, or we get with the remote data in parallel as well the local data in the same area, year, and data domains needed.
Okay. Yeah, it sounds like there can be there are a lot of dimensions of the data, yes. But the nice thing is you're still building the data architecture. So it's really nice to have you here so that you can see also from the later presentations, what are the different users interested in, and then also later in what format can that remote sensing data be available. And I'd love to see as we move to the future that we all start to harmonize how this data looks so that it can be interoperable. I'm
how to exchange the data set so that we can use each other's data seamlessly. Yeah. So that is also one of the big hiccups what we face in the daily work of our day.
Yeah, and again, as a project designer, a lot of time is spent on designing what data we're going to collect. So if we could skip that step and adopt a sort of common framework, then we could spend more of our resources just getting on with collecting the data. And again, at that endpoint, once we have it, instead of designing a new system one by one of where to hold that data, it would be very useful if there could be more of these common these initiatives that bring that data together. Yes. I will say also, just on the methodologies, it's another challenge we have is that the metrics that we use can be different. So even within UN agencies or different multilaterals, there's a lot of projects right now on measuring and monitoring plastic pollution. But if we're using different metrics and methodologies, we miss out on benchmarking. So we can't compare, is the amount of pollution we're seeing here
equal more or less compared to the place.
Yeah, so harmonizing those frameworks, both for the measurement but also the monitoring, is going to be so useful in the future.
And if you allow, Janet, this is one of the beauties of that project, because if you have all on the same bookshelf in the same warehouse and you see the data next to each other with the methodology, with the way how it was derived, you have additional input back when it comes to the ontology and the taxonomy, that we are moving hopefully in a more harmonized, as you say, way of definitions, reporting, and sharing the data in order to speak and read the information in the same way.
Yeah, maybe just one question more. I couldn't agree more with all of that. The Alliance to End Plastic Waste has an impressive membership of all the large companies involved in that plastic value chain. Why are they interested in all of this data and supporting the data coming together? Do you think they may also be users of remote sensing data?
The Alliance to End Plastic Waste is not interested. It's not only interested to close the data gap. There is a lot of work happening in the area of improving the circularity, the availability gap, the infrastructure, in order to set the right interventions and to bring up the best projects in order to improve. We need to have the factuals, the data in the background, and hence this is a project which is supporting each other, and the remote sensing data is a part of get to know your landscape. Have the facts in place, know what is going on, and also monitoring the progress in order to see how the improvement is working and to take out the key learning, what works very well in a certain archetype, in a certain region, in a certain city or type of city, and how can it be replicated? Because that's the other interest of the Alliance, to have projects which can be easily replicated and to get further in other areas.
Yeah, great. That's great to hear. So thank you so much, Sabine. I'm going to let you pause for a minute, but don't go anywhere. We'll come back to you at the very end. I'd now like to welcome Amandine Declerck from Suez to give her to come online first. Maybe open up the video. And yes. There we are. Hello, Amandine, how are you?
Hello, thank you. Thank you. I'm fine. So I can share maybe my screen.
Yeah, please go ahead and share your screen, and maybe if you give a quick introduction of yourself, and then you can get started.
Thank you. So, hello everyone. My name is Amandine Declerck. I work for the Suez group in France, and I am a physical oceanographer focused on the marine litter study. So I will share with you today the Suez point of view and Suez action on marine litter fighting, and our ESA project, a feasibility study named Plastic-Less Society. So I'm trying to share. Excuse me, I try to share in the right way my screen.
Do you want, are you having trouble with the share screen button, or is it the, hey, there we go.
Good.
Okay,
good. If
let's go full screen. Perfect. All right,
okay.
over to you.
So I will begin my presentation to present you our group. So the Suez is a leader in water and waste management around the world. Environmental protection is very important for the group, and to preserve and restore the earth, we have three main engagements. So fighting climate change, preserving biodiversity, and protecting the oceans. To do that, we use our expertise to reduce pollution of the marine environment, to limit terrestrial sources of pollution by changing the waste life cycles toward a more circular model, develop solutions to reduce pollution that originates on land, combining our expertise in water and plastic waste, and finally constantly evolving solutions thanks to our innovativeness and research networks. So Suez is engaged in several actions regarding marine plastics. We consigned the lab laboratory to analyze, test, and characterize plastics. The aim is the formulation of new recycled materials for industry. We can also cite the TerraCycle partnership to marine litter collect and recycling. So in this partnership, we contribute to 25% of marine litter plastics recycling in the Head and Shoulders shampoo bottle, as you can see here, and some other plate of beach with 100% of marine plastic recycled were shared during the G7 in Biarritz in France. We are also a founding member of Alliance to End Plastic Waste, which supports the development and financial support to innovations and action on environmental plastic collections. What we need to go further is to determine marine plastic deposit and processes. So to quantify marine plastic amounts and the collect capacities from global to local. And to do that, the satellite observation will be a good contribution. We will use also this knowledge to reduce the marine litter discharges at source and support the optimization of collection effort by intelligent guidance and decision aid tools. And finally, all this objective will also encourage the evolution of global to local policies. So our main objectives are to preserve the environment and to support a sustainable economic development of coastal regions. To preserve ocean and littoral environment, a center of expertise named Rivage Protect is localized in France, and I'm a member of this center. Our mission is on marine and water environmental division is to develop and offer innovative services to support the reduction of marine pollution. This is done by supporting professionals and local authorities in the environmental management of coastal and aquatic environments. Also to be at the front of a blue and sustainable economy, to provide innovative solutions to meet the territory's challenge of today, but also tomorrow, to support industry in their onshore and offshore operations, and to participate in knowledge improvements of the R&D. Two main objectives guide our work. Firstly, to improve the knowledge about marine litter. So today there is no direct measurement of litter quantity at sea, and there is only few data punctually available. So the aim is to promote traditional but also new monitoring approaches to support the interception efforts as a contribution to the monitoring, to sort and analyze marine litter found in coastal area, to have to increase the knowledge of the kind of litter that we can find, and to develop numerical modeling capacity to support all these investigations. The second objective is to fight against existing marine litter pollution by enhancing litter management and marine litter reduction strategy. To do that, we propose to identify litter sources and possible reductions, to monitor and support collection inflow in the water environment, and to identify the best interception strategy all along the litter pathway. So these two objectives have carried out collaborative research on marine litter issues since more than 5 years. Our partners gather stakeholders, science and technical teams, but also associations working on ocean environmental preservation and the more scientific fields. These collaborations were done in several research programs, and we can cite the Life Lemma projects, focusing on marine litter management strategy in the southeast Bay of Biscay. The micropolit project focused on the micropollutants again in the southeast of Bay of Biscay, and the FML track projects as part of the user uptake program of Copernicus. And today we work on the ESA feasibility study named Plasticless Society. So I will present to you now what we do in this particular project using satellite observations. So the main objective of the Plasticless Society is to assess innovative services answering needs to achieve a plasticless society by involving space assets. So the main activity are requirement consolidation, propose innovative solutions and services to assess technical and commercial feasibility, and to propose a roadmap for future implementation. With our consortium composed of Suez, Telespatio France, and Recyclon, we choose to address the environmental monitoring and the plastic in a circular economy. The environmental monitoring should use the multi-technological solution to support the definition and optimization of marine litter interception strategy. We propose to study the capacity of the detection of marine litter hotspots using satellite observations, to monitor the possible river inputs using videometry as a possible input of litter towards the oceans, and to complete all this observation with numerical modeling to predict litter hotspots at local scale. All this data will be processed to provide user-oriented information and decision aid tools for marine litter management. So the satellite Earth observations will highly support the marine litter tracking at sea. The observation will derive from high-resolution optical imagery as Sentinel-2 or Landsat-8. We explore direct and also indirect hotspot identification assay, as you can see on the right side of the slide. So in top you will find the direct detections, and on the bottom the indirect detection based on front detection as possible accumulation area of floating materials. Satellite will also contribute to help for navigation and communication between our services and teams on fields. Marine litter fighting needs to be integrated in a robust business model. For this purpose, we envisage an integrated circular economy channel from the collect of marine litter to its revalorization, with maximum local involvement, starting with the fishing sector. So from the collect to the recycling and optimization regarding local possibilities and specific deposits must be synced. Must be sought, sorry. And to conclude, Suez for Ocean acting to limit environmental pollution. So for that, several initiatives launched to raise awareness, recycle materials, and limit marine litters. combination of Suez entity as the Suez Ocean and the Suez Waste branch will contribute to do it. Finally, we need to quantify marine litter deposits. So this can be done using innovative technologies to monitor and observe plastics. And in Suez, it is very important to develop partnership to gather scientific and technical collaboration to achieve plastic depollutions. And we want to thank ISA for the invitation and the support in all this project and the opportunity for us to be here today. Please feel free to contact me if you have some questions, as we will not be able to be with you at the end of the session. So you can find my email. Don't hesitate to ask all your questions. Thank you.
Okay, so this was a wonderful presentation. Thank you so much, Amandine. And since you won't be able to stay until the end, I'll try to capture some of the questions here and in the Padlet. Firstly, I was wondering, now you're Suez is a known for waste management, but in your area of work, you're also looking at the monitoring as an important form of data input into further improving the prevention of waste pollution. I wonder if you can have any preliminary financial assessment of the financial viability of the approaches in remote sensing through your work. Is it yeah. Do you know, is remote sensing is it cheap? Is it you put the satellites are already running, so is it actually quite affordable, or are there costs involved? What do you see as the financial feasibility of remote sensing for marine debris?
From my point of view, we can't have a global answer. It will really depend of the kind of the service that we and the level of technological services that we can deploy. As I said, our services are based on several techniques from satellite observation that could be affordable, but also modeling tools and videometry tools. And if we consider the whole package, it could be more, how to say, it could need more financial inputs. But we think that using circular economy from the plastic collection optimization will contribute also to finance the monitoring and the fighting against plastic.
Another question on the financial side. Who do you think are the main or should be paying for the remote sensing? I mean, what sources of funding should we be pursuing to improve the systems and the financial viability over the longer term?
Multiple sources will be the best approach to do it. Yes, as governments, coastal cities, industry also as Suez can contribute. So yes, the multiple approach will be for us the best way, and I think it's the main conclusion of our commercial viability study that we are doing in the Plastic-Less Society project.
And a question, another question before you go, from Milton: if the remote sensing algorithms that are used for marine plastic detection, are they available for sharing?
For now, they are not available for sharing. It is sorry. Yes, it is under validation, and the algorithm are developed with the collaboration of Telespatio France, Telespatio Group and the Telespatio France branch. So it is part of the project and of collaborative action.
Okay. Great. We have more questions. If you can stay for a few minutes to type in the Q&A, if possible. Otherwise, as you mentioned, we'll put your email in the information for participants so they can follow up with you. So thank you so much, Amandine, for your presentation from Suez. We're now going to move to different industry with Vitor Verdelho. Hi, Vitor. How are you?
Hello.
So do you want to go ahead and start sharing your screen?
I'm doing it.
Great. And if you could start with a short introduction of yourself and then go ahead.
Thank you, Janet. And by the way, let me tell you that you are doing a great job. Fantastic chairmanship to this. It's a pleasure to be here today to speak about the ABA, the European Algae Biomass Association. My name is Vitor Verdelho. I live in Porto, Portugal, and I am the general manager of EABA. EABA is an association with nearly 200 members that includes half of them are large companies, small companies also, and half of them are academic members. So we try to combine both academic and industry. So today I'm going to speak about the relevance of remote sensing for marine litter detection in seaweed harvesting. There are basically two large groups of algae: the very small ones, the microalgae, and the big ones, the seaweeds or macroalgae. The microalgae are composed of phytoplankton that provides more than 50% of the oxygen that we breathe, and the seaweed are the ones that you see in the seashores. And now I would like to tell you where is a possible connection with marine litter and the detection technology that already exists. So first, I would like to go through the problem to show you what is the problem. And I will start with the Atlantic Sargassum Belt. That is a huge bloom of seaweed that exists in the Central Atlantic. And this is just an example because there are many other seaweed blooms in the world. This is at the moment the largest one. So the problem is that for many reasons that I'm not going to explain now, but there is a bloom of seaweed that represents 20 million tons every year arriving to the seashores. And there is an idea that maybe the biomass that exists in the middle of the Atlantic is around 600 million tons every year. This is a lot of biomass, and this is how this is the distribution of this biomass across the Atlantic, and what was the evolution along the years. As you can see, it started south of the Sargassum Sea and got a very large dimension. Eventually, as a result of the nutrients that arrive from the rivers, mostly the Amazon River. And what is happening is that somehow the Amazon forest is going down and the seaweed are growing up. So we are having nature found a way to bring the same effect in the ocean. So the nutrients that come from the Amazon River go into the ocean, are taken by the currents, and by some phenomena that are complex and that would take long to explain. This sargassum came from the Sargassum Sea to the south, and then hot water, algae, and nutrients bloom. To explain a little bit more about this, let's see what is the Sargassum belt. What is this sargassum? What is this seaweed? And how this came up? There are mostly 3 species of this sargassum, which is quite interesting because usually we see many species and it's very complex to detect and to find the patterns to detect the seaweed. And here we see that there is a distribution of the relevance of each species in different places, but they are quite different, the different species. We can see here how they look like, the sargassum. Sargassum was originally given the name by the Portuguese sailors that started to sail to this region and called it sargassum. So we have these 3 species. These species are increasing in quantity. Here you see some pictures of how they look like when they get to the shores. First glimpse of this, you see it's a huge problem in the islands and in the places where they get, places that were beaches where the tourism was flourishing. Then the tourism is killed by this quantity of the seaweed that accumulate in the seashores. So again, you see here how this is a problem. So I'm trying to show the problem. Huge quantities of sargasso accumulate along the seashores. And once it's there, it's of course possible to remove it. But it takes a lot of work and it is costly. Ideally, we should prevent that it gets there. So here you see how complex, how costly, and how damaging to the tourism it can be. So as a conclusion about the problem, we can say that there is a seaweed bloom in the Central Atlantic. This bloom is becoming larger every year. The bloom consists in 3 main species, which are known, so it is possible to isolate their spectral characteristics. The bloom is floating. Most seaweed do not float. Most seaweed are attached to the rocks, but these sargassum are a specific group of seaweed that is floating. So therefore, it is easier to detect. They are in the surface, and parts of the blooms move with the current. So as it is floating, it's not attached to the rocks. It moves and it goes to the shores. So these 5 characteristics are critical to think about. So let's think about the solution. The solution for this problem is, of course, to harvest instead of collecting in the shores. It's to harvest in the ocean. But to harvest in the ocean, we need to know the quantities that are arriving, because they are not everywhere. We know when they arrive because the currents move and change along the time. So remote sensing that is currently being thought for marine litter could be used also complementarily to find the seaweed and to optimize the collection of seaweed. So and this is becoming a hot topic of research to move from just litter to seaweed also. And then once we know the quantities of algae, of seaweed that are arriving, we can have different types of harvesting devices. And we can harvest close to shore or far to shore. So depending on the quantities, when, how, where, we can select the best ways to harvest, what kind of nets can be used, and so on. So remote sensing is critical for this, because the boats cannot go just to the ocean and harvest randomly. They need to know what the currents are taking. It's similar to what they do for fishing. So different kinds of technologies can be used to avoid collecting the seaweed in the shores and harvesting in the ocean, closer or far from the shore. So the benefits of all these. It's to transform a problem into a resource. At the moment, these seaweed are a huge problem because it damages the tourism, and it is necessary to collect these, and it has a very high cost. But we can transform this into a resource. In 2020, EABA, the European Algae Biomass, organized a technical webinar about this problem and started to discuss and to see how this sargassum could be transformed into a solution. And in the Caribbean, Anne Rocher published in 2020 a very interesting report that is available online that shows what kind of products we can make with sargassum. So with 1 ton of fresh sargassum, there is a wide variety of possible applications. It's not possible to do all at the same time. Some of them exclude the others, but this is a theoretical framework. So, this is what I had to tell you. Thank you very much. Please feel free to ask any questions.
Okay, great. All right, I learned a lot about sargassum. I have just a technical question. Can it be used as a proxy? If we're using remote sensing to detect the sargassum, can that be used as a proxy for detecting plastic pollution? Are there any correlations between the location of sargassum and the location of the marine debris we're trying to identify?
I don't think that the locations are the same, but there are many connections. The technologies to the data about the specific spectral characteristics of the seaweed can benefit from the data that is already being used for plastics. Another topic that I did not mention is the potential role of the seaweed to help in collecting microplastics. Because if you have seaweed can help to collect in areas where there are a lot of microplastics. The seaweed body, the surface is with polysaccharides that attract the bioplastics. So if the seaweed are in the middle of an area that contains a lot of microplastics, they will be attached to and collected by the polysaccharide mucus that is around the body of the seaweed. If you experience to go to touch seaweed in the shores, when you go to the beach, you see that it is somehow not very clear. It's a mucus polysaccharide existing around it. And this can attract or attach the microplastics. And later on, when you process the seaweed, because of the different the floating characteristics, different density, the microplastics have a different density from the cellulosic characteristics of the algae. So if you break the algae and if you steer the biomass and the microplastics, you can separate them.
Okay. So do I need to be worried when I'm eating sushi? Is there going to be microplastics in the nori around my sushi, or is it sorted out?
you should not be worried, but there is a possibility. There is a possibility.
So do you have any other ideas about how remote sensing could be improved? Any small additional effort that you'd love to see in the remote sensing community that could support your work a little bit better or could support your industry a little bit better?
Yes, the best thing would be to combine the satellite information with the drones that could be used close to the shore, because the satellite information will never be so accurate as drones that can go near the places where you have the seaweed, and it would improve the characteristics of the information. Also, beyond these, there are regions like the Azores Islands in the middle of the Atlantic, where you have some specific seaweed called Asparagopsis that exist in several islands. And this seaweed, Asparagopsis, called Asparagopsis taxiformis, it's a very interesting seaweed to be used as a feed ingredient for cows to avoid methane emissions. When cows eat seaweed, eat normal feed that contains a small percentage of these Asparagopsis taxiformis, these algae, they do not produce methane. They do not emit methane. So it is a high impact. But to collect this seaweed, you need remote sensing to know where you have these algae. And just satellite information is not enough. You need drones, because this algae, this specific algae, is attached to the rocks. So 2 meters below. So you need to combine both informations.
Yeah, so combining, the drones to ground truth, the data that you're collecting from the satellites. We're hearing that from a few different sources, so it's great to reinforce that also from the user perspective. Okay, Vitor, please stay around, because there are questions in the Padlet for you, and we may have more questions for you in the break or the Q&A at the end of the session.
Okay.
Okay, so now I would like to move to Manuel Cruz from the Port Authority of Aveiro. There you are. Hi, Maria. How are you?
Okay,
That's good.
let's start.
Okay, yes, if you could share your screen.
Yeah.
And please give a short introduction of yourself, and then we will.
Yes, of course. Okay, that's okay, the image? Yeah?
It's perfect.
Okay. So hello everyone, I'm Maria Manuel. I'm the environmental manager from both Port of Aveiro and Port of Figueira da Foz, and I'm responsible for the waste management also. With me, we have Isa Cardoso, is the Port Facility Security Officer, and is an expert on port operation, cargo management, and navigation safety. So any questions about the navigation and later, please ask Isa. Where we are, the Port of Aveiro and the Port of Figueira da Foz are in the central region of Portugal. And I'm here as an end user. Of course, the ports are multimodal hubs, an interface between land and water that serves to transfer goods between maritime, road, and rail modes of transport, and that handle over 80% of global goods trade in the world. Of course, the ports are also an interface between the land-based activities debris and the marine litter that the sea decides to send back to us. Concerning the legal framework, the European ports have the directive, a European directive that relate within a port reception facilities for the delivery of waste from ships. So the port are obliged to have facilities to receive all the waste delivered by vessels and boats. And of course, boats and vessels are obliged by IMO to collect the waste on board and not to deliver it into the sea. The ports also should receive for free all the fishing gear waste and passively fish waste ashore, collect and deliver by vessel or boats, and we need to receive that. The Portuguese ports, under the Portuguese law, of course, also have to collect and manage marine litter that remains in the area under their jurisdiction, with respect to the water surface, the water column, and the seabed of the riverbed. And when we look at the jurisdiction area of the Port of Aveiro, the Port of Figueira and the Foz, and we look at the wet area, we have a large area where to collect the marine litter and to manage. Well, looking talking about safety for navigation, of course, big waste or fishing nets are a problem to the navigation safety. Ships can eat larger waste or debris, putting the navigation at risk, and the small boats may hit medium large waste debris or fishing nets and have both or popular problems. Of course, we are talking about drums, plastic or metal containers, about big structures as the mussel raft that we have in the picture, big trees and plastics, big plastics with a significant dimensions, and that remains in the water column. Concluding, the remote sensing can help ports to early locate the marine litter with some dimension, of course, clean or remove it as soon as possible in order to prevent its spread and the navigation incidents. Thank you very much. I think that's all.
Okay, wow, that was very short and sweet. But so for the ports, your obligation is to support the safety of those boats coming in and out of the port. And it's interesting to hear that the plastic waste can even be a safety hazard for something as large as a boat. But it was an interesting point about the propeller. How often do boats run into problems and need help based on tangling or hitting against large amounts of plastic?
Well, the big ships, I think the problems are few, because we can detect in a more or less easy way the large debris that are in the surface. The small boats this is a lagoon, this is an estuary, so we have a lot of recreational and small boats and fishing boats. They have some problems, of course. The fishing nets in the propeller, they are a problem, but it's not a big and a huge incident. Okay, but we have some.
And so when you're looking for that plastic out there, trying to detect it so that you can clean it up or just let those boats know that it's there, what types of remote sensing are being or are useful to you, and where do you get that information? Or is it the boats can see that information directly, or is it coming through the Port Authority?
I think the Port Authority can invest in some remote sensing that can give some alerts in order to act earlier and prevent accidents, right? If we have some alerts about some large debris, we can go there and remove them.
But who's doing the remote sensing? Is it coming from the other boats, or is it drones?
Oh, we don't have. I'm talking about.
This is a wish list. Okay.
Okay.
Yeah.
By now we can detect this by some video cameras, or about with the information of some fishermen or boat people in boats or in the land that can say, please go there because we have a problem. Let me say that all the plastic that we collect from ships and vessels, and also from the fishing nets, go to the recycling process. Probably the municipal recycling process, other from to the industrial process in a circular economy principle. Okay, so
that's fantastic. I've heard from the upcycling community that the fishing net is the caviar of ocean plastic, because it's so easy. The nylon is so easy to melt down and form new pellets that have a really good quality for upcycling into new products. So it's good to hear that the nets are going into recycling. Yeah. Okay. Great. So please stick around. I'd love to see, well, I think the message is clear. We need some remote sensing so that you can keep your boats safe. I'd be interested to hearing from the following sessions what kinds of remote sensing programs could work in that sense. But also because you have good source of the high quality ocean plastic that people want to upcycle. Okay. Thank you so much, Maria.
Thank you
Please
very
stick
much.
around. Okay, so now we're moving from Maria to Mariana, from AQUA-LIT. Already there and already ready. Hi, Mariana, how are you?
Hello, good. How are you?
I'm very, very well, thank you. Okay, are you able to share your screen for your presentation?
Yes, just a second. There we go. First, thank you for the invitation.
There we go.
Center and Janet for moderating this so nicely. And I am Mariana Lara. I work at General Environmental Technologies. I have a background on environmental sciences, and I was a coordinator of AQUA-LIT project. And I speak in past tense because this is a project that finished beginning of this year. So I came to present the main outcome of this project, which is the toolbox for good marine litter management in the aquaculture sector. But before, I'm going to give you a bit of context. So AQUA-LIT came as a project from two statements. The first one being from the technical paper from FAO in 2017, that there are no global estimates of the amount of plastic waste generated by the fisheries and aquaculture sector. And on the other hand, from the State of World Fisheries and Aquaculture in 2018, where it said that aquaculture is expected to be the sector that meets future demand for food, and that it's predicted to rise by 40% by 2030. So with this shocking information, what we wanted to put together, it was a project that would help increase the understanding and the awareness, but mainly the availability of solutions to tackle marine litter in the sea. So when the production of aquaculture would increase in the world, it wouldn't mean also an increase in the marine litter that escapes at sea. So we were 7 organizations working together from across Europe. And we were focusing mainly on 3 seas, the North Sea, the Baltic Sea, and the Mediterranean Sea, with the idea of the information that we would get from these regions would help us also extrapolate and help other regions to have good marine litter management. So specifically for the project, we focused on the Canary Islands and the Azores and Portugal continental. And I'm going to explain you how we did this. The project was divided in 4 stages, being the first one state of play, where we wanted to put together all the literature out there related to marine litter. We wanted to increase the knowledge by involving aquaculture stakeholders from VC basins and do a scanning of the existing tools. From these 3 activities, what it came out, it was firstly a marine litter inventory, which is a knowledge base of the marine litter that can be found that is related to aquaculture activities. And I'm going to show you this in a bit. And regional maps on aquaculture leader, which would be a visual way of seeing the geographic position of the aquaculture facilities with the quantitative data that we have for aquaculture related leader. So the marine leader inventory, this is the downloadable version where it can help us identify with examples of photos and descriptions, the type of material, the type of items that we could find, and also the type of species that could be related to it, and the type of aquaculture. This marine leader inventory is also available online, where the inventory could be screened through the types of leader that is generated, like ropes, clothing, floats and buoys, and so on. It could be explored by sea basin geographically, or see the whole database that we have available. This is an example of the regional maps. Here we can see the percentage of leader that originates from aquaculture and or fisheries. In this project, we tried to focus mainly on aquaculture because it's always put together with fisheries, but in some cases it was uncertain if that leader belonged to one sector or the other, of course. And we also tried to create the maps where we could see the aquaculture leader related to the type of aquaculture developed. So we also published a compendium of all the available policy tools and measures that exist in terms of marine leader from the aquaculture sector at a global, European, regional, and national level. And this allowed us to move to the second stage, which was the learning labs. Here, what we did was creating different workshops with relevant aquaculture stakeholders from the Mediterranean, the North Sea, and the Baltic Sea, to try to first to understand the barriers that they faced for having good marine leader management. And once we targeted these, like that we identified them, then we co-developed with them potential solutions that could help tackle these barriers. So this is what fed the main outcome of the project, which was the toolbox against marine leader. And that it addressed the issue from a preventive and reduction stage, from monitoring and quantification of marine leader, or from the removal and recycling of marine leader. So the toolbox, basically what it presents is first more than 400 ideas and solutions and measures to tackle marine leader at sea. These measures can be consulted either by stage, by measure, by sea basing, or by type of aquaculture. And by this, I mean by the prevention and reduction, monitoring and quantification, and removal and recycling. When I mean measure, it's by maybe knowledge-related measures, or maybe measures that have to do with legislation or with responsibility, or where we need external support, maybe. And by type of aquaculture, we focused on fish, shellfish, and seaweed. So this is a mock-up of how it looks like once we access one of the solutions. It shows from the categories it belongs to, it gives examples, it gives the related barriers that were identified to related to that solution. And then if there are good practices, like already organizations or actors doing something, implementing such solution, then that can also be found. We also have a port facility section where the idea is that through the, we can access directly by country information on the different ports. The information that we provide is if these ports, like it was mentioned before by Maria from Aveiro, if these ports have the facilities to receive of waste, if they do, what type of waste, if there is a fee or not, if there is any limitation for receiving that waste, and then a link to those ports on where they could find more information. Basically, with all of this, what we want to do is to facilitate the good marine leader management at a local scale. And funding opportunities, we collected all the different types of programs and organizations that fund usually projects focused on marine litter, because we wanted to give the tools that if someone wanted to implement a project related to good marine litter management, they could know where to find funds. So that is also available in the toolbox. We wanted to encourage that this toolbox would be a living toolbox, meaning that these 400 ideas and solutions that we are providing might not be everything that is out there. So if someone is interested in submitting some type of solution that was not available in the toolbox, then there is an option for feeding the toolbox. So the idea is that this is something collaborative that continues growing. Later, we have access to the marine litter inventory that I mentioned. And finally, action plans and policy recommendations. So we created 2 versions of the policymaker recommendations. One that is this simplified version of the infographics mentioning the main or the key policy recommendations that we are suggesting. And then we have the full report also available there. And we created action plans for Portugal mainland, the Azores, and the Canary Islands, where based on their status on aquaculture development, we provide some recommendations on the solutions that we have available. So for easy access, we also created this toolbox as an app, and this app can be available through the App Store. But it's not having all the sections that I mentioned. It's having the solutions, which is the main outcome of the project. But for having access to all the other material, then it is accessible through the website AQUA-LIT.eu/toolbox, where you can explore it. So that would be everything from my side, and then I go back to you, Janet.
Okay, thank you very Mariana. So so for you, is the use of remote sensing and the data collected from that to identify where the plastic pollution is that going to help you communicate where there's a high risk that there's plastic in fish stocks that we're eating?
Yeah, that would be very, very useful. The information that we had in all the project didn't come from remote sensing. We did have some coming from drones, for example, but as technology evolves and as all of this keeps moving, we are happy to include that type of information, which is why we made this submit info category, so we can keep including, and the toolbox can keep being updated with all this.
Yeah, and so if remote sensing techniques identify areas that are relatively low in plastic pollution, or even maybe free of plastic pollution, would that be a sensible place to put an aquaculture farm? And if that would be the case, could that farm receive some certification in the future? Do you foresee that we are going to need products from aquaculture to be certified plastic free? I mean, is that going back to my sushi? Do I need to look for plastic free sushi in the future? And can you help with this?
I think that eventually we will have to have this type of certifications. There are already some in place, and there is already, for example, a best practices framework by the Ghost Year Initiative. But I think that more than the fish or the product having plastic, I think it's also related to the practices of the aquaculture facilities. So how a good management plan is in place to actually avoid litter escaping from the facilities. So this is something that definitely has to be enforced, and especially as aquaculture is going to have such an increase. So this is something that we need to pay attention to, definitely.
Yeah, for sure. I mean, the risk of the plastics entering into our food chain are really commonly cited when it comes to plastic pollution. So it's interesting to hear how the remote sensing can help us understand where there's a higher risk, or how maybe can help inform those certifiers of the future. Can I ask just a final question, what types of remote sensing have already helped, or do you sort of see as being having the most potential? Is this an area for the drones? Is this an area where we can use the larger coverage of satellites? What, in your opinion, is the correct form of remote sensing that would work?
In my opinion, drones would be something that has to be pursued because it can provide us more information, more detailed information, whereas satellites, we need so far big patches of litter clumped together to be able to spot it, I would say. And also drones are more accessible, and you know, it's cheaper and easier to fly them. So this is something that should be part of a monitoring plan for sure.
Okay. Wonderful. Okay, so thank you so much for your insights now. What I'd like to do is take a little break and invite everyone to go to the Padlet. I'll pop it in the chat again. And I'm going to show the current status. So this is where you can ask some questions. You can ask Mariana some questions about plastic-free aquaculture, or the toolkits that she mentioned. I did think I saw in the chat, if I can look at my other thing, a request to Mariana to put links to the funding into the chat. That would be great. So you can put your questions here under the questions to speakers and just specify who. So we had a question for Vitor here. Oh dear, I'm behind on answering questions here. So if you could we could take a few minutes that you could enter the Padlet and enter some questions here. You can also give us some comments or suggestions in this area. So we have some suggestions. I saw this one earlier, I quite liked it, about data collection tools on private boats. Can we put some sort of sensor, whether it's a GoPro or other types, onto private boats, make use of that global fleet? Thought that was great. And also the nets, of course, under the boats. That's a good idea. Perhaps that could work for the Port Authority because you'll have more live data as well, so you can secure the safety of the fish. Okay. So not seeing more questions here. Here we go, there's one on ocean debris and drones being based in Hong Kong and have been focusing on ocean debris. We do use drones in a lot of our work. Not sure of appropriate channel here, but looking for high res beaches. That's great info. And I see the IOCC task force has already responded. And do we have more questions? Then in the Q&A, we also had a few questions here. Many have already been asked. Need to read. A question for Maria. Maria, do you think that ports are hotspots for marine litter? Maria, are you able to come online? Are they hotspots?
Well, I think we can collect a lot of marine litter and detect, of course, in our area, not outside our area, not on the sea or or the inside waterways, but ports also are being collected the marine litter that the vessels brings to us, and also to clean our area. So yes, we have a lot of marine litter there.
Yeah.
And can test new technologies, of course. We have
Okay.
yeah.
Welcome invitation to come to your port in Aveiro and test technologies there.
Yeah.
Great.
Okay.
Oh yeah, there was a question also to me on artificial intelligence. Do we use deep learning for the detection of plastic shapes by the cameras? Unfortunately, not. We're using more simple machine learning now. But I wish I had that capacity in the project since we're out there in all these cities. So another instance where I wish there was more collaboration in this space. So that would be great. But then again, I must say on this, our remote sensing is going to a GIS data sharing system that's technically open source. So the images that are coming onto that platform are going to be organized in very nice data sets and available for others who might have more advanced artificial intelligence capabilities than we have in our project with Japan Space Systems and Keio University. Sabine, on the UN hotspot monitoring, I'm glad this question came to you and not me. You mentioned the hotspot methodology. Could you explain in more broad terms? Sabine, I don't know if you want to come online and just give us a little blurb about this.
Yeah, sure. I have briefly answered already. I can also provide the link to get to the documentation, as there are a couple of different methodologies out there how to derive with mismanaged and leakage of plastic waste. We have, with some evaluation and discussion with the different stakeholders, decided to go with the UN hotspot methodology, which is also applied already in a couple of countries to come up with the reports. And we have chosen that methodology because it is going and define then or come up with the hotspots based on the polymers and the application. So it's not only providing an overall plastic conglomerate, but it provides you which type of plastic, like if it's the flexible packaging, is it a bottle, is it a food bag that is then appearing in the leakage and in which amount. And it is a very concise, comprehensive, documentation. So it includes that there is also a proper data gathering and a data assessment to understand the baseline, meaning how much of the different plastic is consumed, then how is the collection and the collection infrastructure, where it is ending in terms of is the municipal solid waste ending in the waterways or in an open dump, because then it will be ending up in the mismanaged, is it ending up in recycling? Is it collected formally, informally, and with the runoff factor, because it depends on how much rain is in that region and what is the situation of the soil, how much of the mismanaged is then really leaking into the waterways. So that's why we have decided to go with that methodology. However, we do have also all other leakage rates, which are around from the different models in PRISM, and we have linked that to each of the different methodologies to provide also, as I said, to have all the data on the table and use it.
Great. All right. Thank you very much, Sabine. Okay. So another one on plastic leakages. To me, at the moment, quantifying plastic leakages into, for example, waterways is one of the key challenges. I agree. By who wrote this? Is this Anon? Yes, and it relies on very big assumptions. How are you accounting for this in the Closing the Loop project in a way that is realistic? And a more general point of discussion, how can remote sensing help in assessing this better? So key challenge. How are we counting for this? Right. So we're using the plastic pollution calculator, which is a sort of a mass balance approach. So we know that the plastic waste that is being produced in a city has to end up somewhere. If it's not ending up in the landfill, then we know that it's either being openly burnt, that's going into air, or it's going, it's dumped on land somewhere, or it's going into the waterways. So the model helps us to see if we've missed anything, because the plastic can't really plastic waste that's produced cannot disappear. So we do a lot of primary data sampling at the very beginning. This is why I said it's the measurement of plastic pollution is very different to monitoring. Measurement is data intensive, expensive. It can be quite, it involves a lot of people and a lot of coordination. So it's not something you can do that often. Whereas the hope is that remote sensing can help to automate the monitoring process between these big data collection efforts. So the assumptions are in the model, and you can account for this by doing the primary data collection and then sort of checking and validating. Now, there's a lot of discussion going on about how methods like the plastic pollution calculator can be complemented by remote sensing. Because when we first started, the cities were saying, well, what's the difference between this? Why do you need remote sensing when we already went and collected all that primary data collection? And they even said, why do we need that model for the plastic pollution calculator when we did all that primary data collection? So there's a lot of unpacking what all this stuff means. But essentially the plastic pollution calculator helped us identify hotspots. And that helped us set the areas of interest, which we used to define where the remote sensing would take place. So we couldn't do remote sensing in the whole city. We had to focus on the hotspots. And we also chose some not spots, what they call, where we're not expecting any plastic pollution. And that way we can use the remote sensing to validate the results of that baseline report. So this sort of validation of the model and calibration of the model is also very helpful. So I could actually talk on that for a long time, I've realized. Once you get into this topic, it's a bit, can become an obsession. Okay, so any other questions from the Padlet? Or I saw this one here from the Eureka Clusters program. You know, we're talking on and on about coordination and cooperation. And then here we go, right in front of me is this offer to collaborate internationally, including the contacts. So thank you, Xavier, over there for highlighting this here. Then there's also sky flocks. Is that like a flocks of birds? Sky flocks from the European Space Agency, or at least a spin-off company, developing orca. Oh, I like the links to the sort of animal terms. So using commercial aircraft as a platform to carry small equipment. Yeah, imagine if aircraft could carry, what would they be? Optical and radio frequency constellation. Okay. Yes, I agree with this. It's a really interesting idea. Maybe Sabine, can you integrate data from Skyflux into your Prism platform, or maybe Mariana into your toolbox? Could that help you as a user of this type of data?
I have seen this. I need to talk to my project team. I am not in the position to answer that right away. But I have already sent it to the team, and we will look into that case for sure.
Wonderful. Oceans Asia is using drones. Also, perhaps that's of interest. Aerial images of litter on beaches around Scotland, scrapbookscotland.org.uk. So lots of sources of data. You almost need an artificial intelligence algorithm to go and find all this data and help put it into harmonized data sets. And we're going to hear a little bit about harmonized data sets in the next session. Very general question I'm getting is, what about marine litter monitoring for feeding data to policymakers? What would be, in your opinion, the minimum input remote sensing could provide to take action? Yes, thank you. So we, policymakers, with all of those policy goals to prevent or reduce marine debris, what they need to know is how much marine debris is out there. That's actually difficult, so because the accuracy is not there. So what could help is it getting bigger? Is it getting smaller? And where is it? If possible, also the pathways, if you can, if we can detect where the movement over time of the marine debris, where is it coming from? All right, as we near the end, I'd like to come back to my speakers. If you could turn your cameras on and join me up here. Maybe we could just go through one by one. I would like to see what is the main gap you see in the current applications in terms of data that remote sensing could fill. Just one gap, you're queen or a king for a day. You get to decide, what does the remote sensing community do to support your needs? What is that one thing you would like to see done? If we can do a quick round. Shall we start with Sabine?
I was afraid that I will be the first in the list. Okay, thank you, Janet. So the main thing what the remote can do for us, that's a hard one now for me to answer, because I think it's something on both ends. Yeah, what we can do for the collaboration in order to be able to host and to give a space in our database and to process the data. So I would. I think I'm not in the position to answer that question as you are looking for.
All right, Mariana, now you're queen for the day, and you get to decide remote sensing community does X for you.
Yeah, I mean, it was mentioned in one of the presentations at the beginning. I think that the best it can do is provide enough data, right? So like we said, like we saw before, now data is very punctual and we know the problem and we know, but you know, it's like constant monitoring and so on, and in certain regions. And we saw that when trying to put together the regional maps, there were many countries and many coastlines where we didn't have information from. So I think that remote sensing has the potential to cover that gap. Yeah.
Great. Thank you, Mariana. And Maria, over to you. Queen for the day.
Well,
what would you like to have?
No further experience on these technologies, but I think the main challenge is to adequate the technology with the litter dimension, and also the alert time, because it's not the issue to have an alert in 1 day or 2 days after. We need to have an alert on the right time. So I think this is our challenge, to define best technology and the best, the most adequate to our problems.
Yeah, Wonderful. I would like to also be queen for a day and say the number one thing you could do is share the data sets and the algorithms so that for those of us who are collecting the data to support the policymakers, we don't need to invent that tricky part. We can just use the best available algorithms out there and do that. And maybe a little help desk so that I can call someone every so often when we get stuck, especially at the beginning when we're designing the projects. Okay, so now did I lose Vitor, by the way? Vitor, did you want to be king for a day? Going once? Just queens, just queens today. Okay, great. So then I would love to thank the speakers for sharing their expertise and their opinions on this matter and their time. Really grateful for all of your wonderful presentations. Yes, thank you. Thank you to all of the participants for your questions and your active engagement as well. We'll try to get to questions again as much as possible on that Padlet. It's not going anywhere, so come back to it if you like. Now, the next session starts at 5 p.m. Central European time in 2 hours, if I'm not wrong. And you can use the same Zoom link to access it. And I believe there is also, you can go back and watch the live stream on YouTube. And if you can't attend the next one, you will also be able to see that on YouTube later on. Okay. So on that note, I'd like to thank everyone for a really informative and fun session. I learned a lot and I'm looking forward to seeing you in the next sessions where we'll learn more about the technologies.
Thank you.
Thank you, everyone. And thank you, Janet.
Okay.
Thank you.
Thank you.
Bye-bye.
Thank you.
Bye-bye.
Next session, Tamona, is in 2 hours, depending on where you are. I don't know where you are, but it is 5 p.m. Central European time. Thank you, everyone. Thanks, Milton, for your questions. Guillaume, thank you.